Good morning, everybody. This is a live emergency update as Tropical Storm Fred is intensifying on approach to northwestern Florida, and it's even wobbling a little bit off to the northwest. Minimum pressure is down to 993 millibars, and that was confirmed by Hurricane Hunter aircraft as well, extrapolating that sea level pressure down to 993 millibars. So quite a dramatic update so far this morning. And I could show you that real-time data here as well that is coming in. There you can see that satellite imagery, though, definitely showing that compact inner core. It might be starting to experience a little bit of southwesterly wind shear. You can see on radar the western edge of that inner core is coming in just a little bit, possibly suggesting that this thing has reached peak intensity. Who knows, though? Even a minimal hurricane can't be ruled out here with all that convection located very close to the center. Here is the latest hurricane recon data showing that minimum pressure down to 993 millibars, and a couple of intercepts of that inner core were noted there as well. An earlier pass showed that 993 millibar inner core, definitely a compact inner core there, and even the wind speed falling down to near calm right in the center of that hurricane as well. And there is a tornado watch that has been issued, and the biggest concern with this tornado watch is that dry slot that's wrapping around the east side of the center. There is a mid-level dry slot that's coming in, and that could lead to just a little bit of surface heating. Have seen an invigoration of those cooler cloud tops right on the nose of this dry slot that is wrapping in there just to the east of the center, helping to invigorate many of these convective bands. And usually the tornado potential is maximized on the northeastern quadrant of these tropical cyclones. And when you get a tilted tropical cyclone like this that's wrapping in that dry air to the east of center, even causing a little bit of a northwestern wobble, that dry slot on the nose of that and the convergence with land as well is helping to lead to vigorous convection there, and even some embedded supercell storms within that. So once that dry slot also comes over land, that could lead to some enhanced instability or surface-based cape as well. And that could also be a problem. The 12Z hurricane models suggest overall that Tropical Storm Fred has likely reached maximum intensity and should level off or even come back a little bit between now and landfall this evening across northwestern Florida. Except for the SHIP model, it suggests further strengthening before leveling off eventually as well. But who knows? Maybe we could even have a low-end hurricane possibly with this system. But I'm going to show this thing to you now on radar. I could show you those convective bands. Looks like we had a hot tower that developed right near the center of Tropical Storm Fred. That likely caused that pressure to fall right down to 993 millibars. And that hot tower has since collapsed. And you can even see just a little bit of some warming tops associated with that. So now I'm heading on over to the Radar Omega app here, and we'll show you that satellite imagery that shows that hot tower. Basically a little supercell storm that has a lot of latent heat release associated with it because of that phase change from a gas to a liquid state. And there you can see that infrared data. We'll loop this as well so we can show you the development of that hot tower and its subsequent collapse. Look at that. And quickly, not a lot of evaporational cooling in there, so not a ton. And look at that little hot tower right there. See that little bright blue? That's a very cold cloud top, so that shows that convection developing very high up into the cold part of the upper troposphere, maybe even the lower stratosphere up there. And then you can see it quickly collapse. And that little eye-like feature took over there. A little bit of warming after that collapse, but then it quickly filled in. And another thing that I'm seeing on this satellite imagery is this dry slot that's trying to wrap around the east side of that inner core. And right in the nose of that dry slot there, near the Florida Big Bend area, just to the south of Apalachicola. Notice those big cloud tops there, right in the nose of that dry slot, wrapping around that center. And once this little dry mid-level air passes over northwestern Florida there, that could lead to some breaks in the clouds and a reinvigoration of that convection within those outer bands, and that could lead to an enhancement in the tornado potential there across the Florida panhandle and northwestern Florida. This wobble off to the west that's happening could bring onshore flow as well out into the Panama City area, which would bring that 2 to 4 foot storm surge within that onshore flow into Panama City, maybe toward Apalachicola. And look at the outflow, upper level outflow here as well. See the banding within that outflow, showing a very healthy, well ventilated system. You get a lot of difluent aloft, almost an anticyclone develops that spins counterclockwise above that convection, and that helps to vent that convection. It helps in the efficiency of the heat transport as well. You get a lot of late heat release in the mid-levels of the troposphere when you get this convection located over the center of a vertically stacked tropical cyclone like this. But you definitely do have this dry air wrapping in. There is some evidence that Tropical Storm Fred could be starting to experience a little bit of an increase in that westerly wind shear too. I'm noticing the western periphery of that inner core maybe starting to erode inward just a bit. You can really see the clear slot well on radar there. And look at that inner core spin up. This inner core spun up there as that thunderstorm right near the center. That hot tower poked up high up into the troposphere. A lot of cold temperatures measured with infrared satellite at the very top of that overshooting top. Also, some of the coldest cloud tops ever are starting to come ashore here right now, right there near the Florida Big Bend, near Apalachicola. And that's right on the nose of this clear slot that is wrapping around the east side of this compact inner core of this tropical cyclone. Mid-level dry air that's coming in, and right on the nose of that mid-level dry air and some enhanced convergence with the coastline there near Apalachicola is leading to vigorous convection there, and even some transient supercell structures within that zone there, right in the nose of that clear slot, could locally enhance that tornado threat. And look at this convection that was approaching the coastline and then gets ripped off to the east by that pressure fall. That pressure diving down to 993 millibars there near the inner core of that hurricane, a tropical storm, tropical cyclone. But you do have this dry air wrapping around the center, coming in the mid-levels of the troposphere. Definitely some dry air aloft. And once that dry slot comes ashore and migrates over northwestern Florida, it could lead to an enhancement in the surface-based instability available to these storms within these different convective bands here. And once these convective bands are able to pivot ashore, you could certainly get an enhancement in the tornado potential across northwestern Florida, where that tornado watch is happening. But notice the western edge of this inner core is starting to erode from west to east. It looks like it just anchored and may have stopped there. So that might be kind of this inner core, the convective burst, and the outflow of that inner core kind of balancing against an increase in the southwesterly wind shear. That could definitely happen with these tropical cyclones where you get that outflow pattern. As the outflow pattern migrates out aloft, and we just saw that on satellite, that clockwise spin aloft of this is basically some ridging helping to ventilate the system. When that upper level outflow banks into the wind shear, it can actually counterbalance the wind shear and act as a counterweight to that increasing westerly wind shear. And just a little bit on radar, it looks like the western edge of that inner core was eroding from west to east, but now it's kind of anchored there a little bit, which tells me that this storm system may be stopping its northwestern wobble and should start to resume its northerly motion toward shore, which would bring it ashore very close to the Panama City to Mexico Beach area. This wobble to the west may bring some of that worst storm surge just to the west of the Florida Big Bend there, because if it continues to wobble off to the northwest and you can actually get some of those southwesterly winds there to the west of the Florida Big Bend, that would bring a 2 to 4 foot storm surge in there between Panama City and Apalachicola, maybe near the Mexico Beach area as well, that area that was hit so hard by Hurricane Michael. So this is the radar showing that inner core there spinning. That's where Hurricane Hunter aircraft just measured that 993 minimum pressure. And it looks like it maxed out in intensity right there when you can see those reflectivities blow up that was coincident with satellite with those very cold tops, that big convective burst, and then that storm collapsed, and then those cloud tops warmed just a little bit, so you could see that reflectivity of that inner core starting to come down just a little bit within that inner core of this tropical cyclone as this thing is spinning out there. Basically a surface low out there, just spinning along, but it is a tropical system, vertically oriented, hot towers all the way up. It should start to transition away from a tropical system after it makes landfall and loses its connection with the very warm ocean temperatures out here. The Gulf of Mexico is warmer in the western Gulf and right along the immediate coastline. So this thing is hitting some of those warmer temperatures located right along the immediate coastline here. That is definitely helping with this intensification process so far this morning as well. Thank you guys for joining me for these live weather reports here. We are live from Team Dominator headquarters, breaking down an intensifying tropical storm Fred here. Definitely a strengthening storm, up minimum pressure down to 993 millibars, maximum sustained winds up to 60 miles an hour here. Breaking this down live. Again, thank you guys for joining me here. Live updates from Team Dominator headquarters here on Tropical Storm Fred. That is definitely intensifying on approach to northwestern Florida. You are looking at the radar data here right now. So we are breaking this thing down live right now. Thank you guys for joining me, tuning in for my morning weather reports here. I'm going to move this on over. So again, we are live here, breaking this down. We just saw that Hurricane Hunter aircraft data that sampled at 993 minimum pressure there. You can start to see an overall reduction in the convection and overall a decrease in the reflectivity within this convection that is wrapping around the inner core. An exception being, though, this convection that's coming into Apalachicola right now on the nose of that mid-level clear slot. So you've basically got a mid-level dry slot wrapping around the east side of this system, possibly suggesting that it has reached peak intensity. And the awesome part is, the incredible part of science here, is that Hurricane Hunter aircraft were able to sample that quick peak. There was a hot tower that you could definitely see on satellite imagery, and you can see on the radar here with that thunderstorm, basically a little supercell storm that developed very close to the center there, almost becoming an effective northwestern eye wall. Look at that thing blow up in radar reflectivity. That was right beneath that hot tower there. That thunderstorm developed, and then it collapsed just a little bit. And you could see that on infrared satellite. You could see it poking high up in the troposphere, collapsing. A little bit of a warming area, just a little circle of some warming cloud tops. And we could see that on satellite imagery here. Let me show you that satellite infrared. On water vapor, you could definitely see that clear slot. It is wrapping underneath some of these high clouds here on the eastern fringe of that inner core, which is quite healthy. You can also see the outflow here aloft, and that's rotating in a clockwise sense, leading to a well-ventilated system, a very efficient heat engine, tropical cyclone, a lot of latent heat release as well associated with this inner core. But if we go on over to infrared, then we could definitely see those individual thunderstorms and the overall health of the inner core. I do think it did reach peak intensity. Look at that hot tower that develops right there. We call it a hot tower, but it has cold cloud tops because it penetrates very high up into the troposphere, where temperatures are a lot colder up there near the tropopause. And so you can definitely see when those overshooting tops poke high up into the atmosphere. Zooming in a little closer, we could definitely see that thing, then it collapses and it's replaced by that little circle of red, which shows a little temporary warming of those cloud tops, being replaced though by some more cooling cloud tops as well, a reinvigoration of that convection near the center. But that was when this thing reached peak intensity. That little flash there of the blue right there, that was when it reached peak intensity. And we happened to have NOAA aircraft within the storm at that time measuring that central pressure, dipping down to 993 millibars. It collapsed, replaced by a little bit of an area of warming cloud temperatures there, and that could signify that it was just a little bit past, that it is just a little bit past peak now. You can also see this convective band unzip there right on approach to the Florida Big Bend near Apalachicola. And that's some enhanced convection just on the leading nose of that mid-level dry slot that is wrapping around to the east side of the storm system. And it's that dry slot that could migrate over land over northwestern Florida and the Florida Panhandle that could lead to a little bit of an enhancement of that low-level instability, a little steepening of the lapse rates, just enough to tip the balance in the favor of tornadic supercells there. It doesn't take much in these tropical environments, and the RAP model is already starting to analyze 3,000 to 4,000 CAPE out here over the ocean, over the open ocean, if you will. Some dry air coming in the mid-levels over top. A lot of that tropical moisture at the low levels creates quite a bit of instability to the east of that center. And look at that outflow aloft, spinning in a clockwise direction. And even if we do have some enhanced southwesterly wind shear coming up just prior to landfall, that could level off the intensification process. The outflow aloft that is surging outward, basically the heat engine releases heat as the convection in the mid-levels. As the convection rises up through the mid-levels of the troposphere, you're converting a lot of that water vapor over to liquid water, cloud matter, convection, rainfall, and as that phase change happens, it releases stored heat energy inside the water molecules. That's called latent heat. And then aloft, you get outflow. And if you have a well-defined high pressure aloft spinning clockwise, that can help to ventilate the system. It helps to transport heat from the ocean surface to aloft in the upper troposphere. That's the purpose of these tropical cyclones, is to transport heat from the tropics to the poles and from the warm ocean surface temperature to aloft in the troposphere. And that's exactly what's happening with this convection very close to the low-level center. A very vertically aligned tropical cyclone as well. So let's now take a look at the tornado potential here, and we'll break down the environment right now that it is nested within. Moving away from our pure tropical analysis and moving on back toward tornado tropical hybrid type of an analysis here. And there you can see over the open ocean, directly underneath that mid-level clear slot and just to the east of the center, that belt of 3,000 to 4,000 CAPE surging to the north and stopping just south of Apalachicola. Right in the nose of that instability is where the strongest convection has happened so far today. So this is the RAP analysis here. And what's that? Basically, that instability nose is able to propagate onshore across northwestern Florida. That could lead to just a little bit of some breaks in the clouds. Even just some breaks in the low-level clouds would be sufficient to lead to just a little bit of surface heating that would tip the balance towards surface-based tornadic supercells. So that's one thing that we do need to keep an eye on here. Let me pull this up so that I can annotate this image. And there is definitely the strongest wind shear for tornadoes is in the northeastern quadrant of these tropical cyclones. And when you get these mid-level clear slots that can wrap around the center, wrap around that inner core, they can enhance the lapse rates just a little bit beneath them. That's why you've got this tongue of enhanced CAPE here, wrapping around the east side of the center. You get just a little bit of drying in the mid and upper troposphere over that warm tropical moisture, and that can lead to enhanced CAPE and quite a bit of CAPE to develop with these systems. Sometimes these tropical storms can be more prolific tornado producers than the perfectly symmetric hurricanes, and that's because of these clear slots that will wrap in the eastern side of the system. And also the strongest wind shear is located out here within this northeastern quadrant. So the greatest coincidence of instability and that low-level wind shear is happening right on the northern edge of that clear slot of that instability nose. So once it's able to advect inland across the Florida Panhandle or the Northwest Florida area, that's when that tornado threat is really going to be on the increase out there. So now we can go over to back to the wrap and look at some of the low-level wind shear. There you can see that 2 to 300, 0 to 1 kilometer shear right in the northeastern quadrant, right on the nose of that dry slot that is wrapping around the east side of the center and stepping forward at 2-hour increments. Notice how that 0 to 1 kilometer shear ramps up across the Florida Panhandle. That includes Tallahassee as well. And notice how the wrap picks up on that northwestern wobble and brings that onshore flow very close to the Panama City Beach area. Look at that clear slot coming ashore there in northwest Florida. And it's also associated with an increase in the convection across northwestern Florida, Apalachicola up toward Tallahassee. And that is going to be a big issue, is the tornado threat with this system in the northeastern quadrant and that clear slot that's wrapping around the east side of center there. Look at that 0 to 1 kilometer shear increase above 200, 2 to 300 there in the Florida Panhandle. So that's definitely what we're going to be discussing today, is that tornado potential. And that's going to be as these convective bands come ashore, and especially as that mid-level dry slot is able to wrap in. Hello? Hello? Take a look at the mid-level lapse rates and see if we can find that clear slot. If anything, they increase a little bit just southwest of the system. These are all geared toward more severe weather type analyses. See if we can see any of that enhanced southwesterly wind shear hitting these storms. See just a little subtle upper level low here just to the south of Louisiana. The other one that was in the northeastern Gulf of Mexico has weakened. And you can see some of that stronger southerly flow there over Georgia and the Carolinas that was impacting the system yesterday. A little bit of southerly flow here, but really when you're moving off to the north at about 10 miles an hour and you've got 10 to 20 miles an hour in the upper troposphere out of the due south, your storm relative wind shear is almost zero, and that's why this thing has been allowed to intensify. The question is, will this upper level low, subtle upper level low just to the south of Louisiana, bring enough southwesterly wind shear to level off that intensity? And that is what many of the hurricane models are picking up on. A little bit of an increase in that southwesterly wind shear associated with this upper level low. You can see that cyclonic spin off to the west of the system. Thank you guys for joining me this morning for this live stream as Tropical Storm Fred continues to intensify on approach to the central Gulf Coast. Looks like it is going to make landfall sometime this evening. Minimum pressure down to 993 millibars. I think Hurricane Hunter aircraft sampled it very close to that peak intensity. Right now, hurricane models are in strong agreement also with that turn to the north happening here. Let me show you the new 12Z hurricane models here from the tropicaltidbits.com website, showing that wobble to the northwest should be done, and we should have a due north movement right toward Mexico Beach, it appears, and anywhere off to the east will have that substantial storm surge, including Apalachicola, a very storm surge prone area there in Apalachicola, and wherever that onshore flow can develop to the west of Apalachicola, Mexico Beach, St. Joe, all the way through Panama City, could certainly have a 2 to 4 foot storm surge as well. That is going to be across the Florida Big Bend. And the intensity models here showing that a level off, except for the ship model definitely showed that intensification, and then the level off. The GFS and the HWRF models did a very good job on this storm as well. And of course, we can show you the hurricane models here. Let's look at the HWRF and how it handled Fred here. It does show that dip down below 1,000 millibars. This is this morning at 12Z, 998 millibar system. And look at that wrap up down to 987. The HWRF incredibly showed what happened this morning with that convection wrapping around the center. It also shows those supercell storms developing within that mid-level clear slot wrapping around the east side of the center. But it did show this spin up here and even the wobble off to the northwest. And it shows, the HWRF shows even a little bit of further intensification on approach to landfall. Very close to Panama City Beach, bringing on that onshore flow, very close to Panama City, off to the east there. Look at all those little inlets. Once that southwesterly flow comes ashore with this stronger system, there definitely could be a storm surge. And this thing shows it intensifying into a Category 1 hurricane with a very compact inner core, that little supercell storm almost becoming a northern eye wall there with this system. It shows that convective band off to the east near Apalachicola and off to the east having tornado potential. That includes up near the Tallahassee area. You can see these little beans within that convective line, within that feeder band here of convection. So the HWRF certainly nailed it. Pretty fun to see these high-resolution hurricane models showing such an accurate depiction of the inner core of this system. But look at that rapid intensification right at the last second. Once it's able to get that convection wrapping around the inner core there, you get all those isobars wrapped around each other, very tight pressure gradient, and then it comes ashore with that onshore flow just hammering Mexico Beach as well as some onshore flow down there near Apalachicola. 2 to 4 foot storm surge anywhere to the east of the center there, and forecast to make landfall much earlier than anticipated yesterday. It looks like a daytime landfall here, about 4, 5, 6 p.m. when it comes ashore, and that's going to bring the worst impacts. And then that low fills in once it loses the heat energy of the Gulf of Mexico, moving overland. But that tornado threat's going to continue across central and southwestern Georgia, south central Georgia, Valdosta, overnight tonight, Albany area, even up toward east central Alabama. Looks like that tornado threat could be maximized within that dominant convective band as it moves inland. And flash flooding also associated with this dominant convective band here. Big time rainfall, east central Alabama, west central Georgia there, and within this feeder band as well. Tornado potential, nocturnal tornado threat increases across southwestern or south central Georgia as well. But look at these big bands feeding into that low pressure system there. Ramping up on approach to the coastline. Beautiful thing to see. This is the 6Z HWRF that definitely accurately depicted that intensification. Here is that updated infrared loop. Showing, this is on the Tropical Tidbit site, showing the evolution of that hot tower near the center. Wow. That was when it reached peak intensity there, likely very close to that. Look at that. Boom, and then the collapse. And then that was, it's like it's reinvigorating a bit again. It's possible that that intensity has leveled off just a bit, and it was associated right with that hot tower developing, followed by a collapse of that storm, a little bit of warming right around that, almost a donut of some warmer temperatures. But you still have that slug of convection wrapping all the way around the center. Definitely not much of an indication that it's weakening right now on approach, so it does look like it continues to intensify. I'm interested to see the next Hurricane Hunter aircraft pass to see if the HWRF is accurate in dropping that minimum pressure down to even a sub 993 there. Let's go back to radar data. I'm keeping an eye on Grace, which right now is a tropical depression just on the south side of Hispaniola. But it basically became an open wave yesterday. Center formed a little bit further south, and now the models are taking it even close to the Yucatan Peninsula, potentially as a pretty stout tropical cyclone. And the threat for South Texas next weekend definitely is increasing just a little bit as well. So it does look like we've got another hot tower here, just on the west side of the center, northwestern side of the center as well, which could be a sign that this thing's going to make another run at even being stronger once again. That is almost like a little supercell storm there. This is the center of Tropical Storm Fred, and then you can see this clear slot, mid-level clear slot wrapping all the way around just to the east of the center, pulling in that drier air associated with that upper level low located to the south of Louisiana. Right on the nose of that dry slot is where you get a big invigoration in the convection and could get an increase in tornado threat. I do think that the short-term tornado threat is increasing near the Apalachicola area and a little bit inland. You can see these supercell storms starting to develop as well as that mid-level clear slot is starting to overspread these two convective bands. You got a convective band here, a third convective band developing there as well. Oops. Pull up the radar here, folks. This is what I was breaking down in real time. So you've got this little convective hot tower here, a little supercell storm right in the northwestern wall here of the inner core of the storm. That's the center of Tropical Storm Fred. And then you've got this mid-level clear slot wrapping around in here to the east of that center. Some little enhanced instability available to these storms, some enhanced lapse rates as well. Vigorous convection then right on the nose of that clear slot up here. That includes this band. You got this dominant convective band. And I do think that the tornado potential is increasing within this band of supercell storms right there. Northeastern quadrant. 200 plus 0 to 1 kilometer storm relative felicity. This convection is wrapping east to west, also has some tornado potential, but these are all little supercell storms over the Gulf of Mexico, approaching the Florida Big Bend just to the east of Apalachicola. So these are what I'm keeping an eye on very closely for an increase in that tornado threat. Carabel area. You're probably have the greatest short-term tornado threat as you've got these bean-shaped supercells that are moving from east to west over the open Gulf of Mexico. Each of these things likely have water spouts in progress as they're moving off from the east to the west, coming ashore here near the Carabel area, basically training one after another, wall cloud after wall cloud after wall cloud, possible landfalling. Water spouts as well could be associated with those. It's one of the big threats in addition to coastal flooding. Look at these mesocyclones with these little supercells. This one could be enough to trigger a tornado warning when it approaches coastline. Usually over water, you have a little bit less low-level wind shear because there's not as much friction of the land surface. The land surface can also increase the speed shear, which contributes overall to the wind shear as well. So once these things move over land, you'll see their mesocyclones intensify as well. But the wind shear in this northeastern quadrant is still sufficient to develop supercell tornadoes even over the open ocean out here, over the open northern Gulf of Mexico. And these are heading off to the west-northwest, and they do definitely have tornado potential. There's also one that's rotating right now right over Carabel area, and you're also getting some gusty winds. Definitely feels like a tropical cyclone there within this dominant convective band of supercells. See that little hook there just to the southwest of Carabel as well, starting to ramp up. A little bit of a convective blob here, a couple of embedded supercells. And then you've got this one upstream that's really cranking, and they keep getting more intense with time as you go out over the open Gulf of Mexico as these are moving off to the northwest, and definitely increasing that tornado potential. Yeah. Yeah, that still is mission 15 is inside Fred right now. Still showing that 993 minimum pressure. Big northwesterlies, strongest winds look to be measured right inside that little supercell storm in the northwest side of the center. And this happened quickly, that minimum pressure down to 993 millibars. It was about 1,002 millibars just prior to that, and then quickly dropped 10 millibars just as that hot tower was experienced. And right now I'm watching those supercell storms coming ashore to the east of Apalachicola. We do have another one of those hot towers, or those little bean-shaped supercell storms that has developed right on the northwest portion of the circulation. Definitely a lot of latent heat release associated with that hot tower, helping to drive that minimum pressure even further down into the basement there. We could loop this thing. Look at that anchor and expand. So it does look like the convection is expanding even further. The H-Wharf does show that further intensification to sub 990 on approach there to the Panama City area. Looks like very close to Panama City. Most of the hurricane models are showing a due north path of this tropical cyclone now. And looks like it just continues to invigorate, carving out a little area of diffluence aloft. The outflow likely acting as a counterweight to that increasing southwesterly wind shear. But that upper level low to the southwest, or just to the south of Louisiana, is very weak. So I don't think it's going to have that much influence. And you could definitely see on radar that dry slot coming ashore, wrapping around the east side of the circulation, overspreading a couple of these convective bands near and to the east of Apalachicola, allowing these things to reinvigorate. You can see the development there of some supercell storms moving east to west, coming ashore in the Florida Big Bend. And once that onshore flow is able to hit the shape of this coastline, the west side of that Florida Big Bend, once those southwesterlies are able to come ashore, that's when you're going to get that big 2 to 4 foot surge. And right now, most of the models are showing landfall this afternoon at about 21Z out here with this. So I thought that maybe it was starting to feel that wind shear just a little bit. I was watching the western edge of this inner core kind of erode and migrate in, but now it's anchored and solidified. So it looks like that outflow is acting as a pretty good counterweight to that westerly wind shear, and it's allowing this bubble up here of convection once again very close to the center, and that thing's even trying to wrap around a little bit, wrap around the south side of that circulation and the southwest side of the circulation, which would lead to even further pressure falls, likely falling even below 990 millibars potentially there. But look at that hot tower trying to wrap all the way around that circulation. Could lead to even further intensification. There you can see kind of an elliptical shaped center to this tropical cyclone there, with that minimum pressure down to 993 millibars. But Hurricane Hunter aircraft is in the center of this thing right now. Much of the Florida Big Bend experiencing deteriorating conditions. Still intensifying here. Time is 9:53 Central Time. Could definitely see those strong southerlies just to the east of the center, even within these little radar echoes there. And man, look at that. The striking resemblance, and basically confirming that that thing is a supercell storm here. But look at the shape of this. I wouldn't even be surprised if there's a water spout ongoing right there, just in the northwestern part of the center of this tropical storm Fred that continues to intensify. I do think that it even has a chance of reaching a Category 1 hurricane intensity. The H-WRF definitely shows that, and it's been nailing the structure of this system since day one. You can even see a little bit of a mesocyclone there within that eye wall. Big northerly streaming into this, streamwise vorticity feeding into this convective pop. See if we can see the echotops as well. See how high this convection is pumping up into the atmosphere. Look at that echotop there. With this hot tower ongoing near the center of this storm, 55, 60,000 feet right there. And we can loop it as well. That was the early hot tower. You can definitely see the cyclic nature of this tropical storm and its dependence on these little supercell storms that have developed relatively close to the center. Look at that echotop. Boom, look at that echotop. So it looks like it's going to make another run at a stronger storm. It probably has not leveled off. And I could even see this thing intensifying even further. Maybe sub 990 is definitely in the cards. Especially with these supercell storms that will develop very close to the center. And the west side of the center right now as well. Kind of confirming that this is a relatively vertically oriented tropical cyclone. Look at the inner core here. This big leaf of convection spinning around the western side with a supercell storm within it. We could definitely see that supercell storm here on echotops. Convection pumping way up high into the triple pause there with this system before it makes landfall. So depending on what Hurricane Hunter aircraft data show, and I am keeping a close eye on it, I'm waiting to see a lower pressure fall to see if this is intensifying even further. Definitely some of the highest echotops anywhere, and it's very close to the center. You've also got this convective feeder band out over the northeastern Gulf of Mexico that'll be coming ashore up here eventually too. And then you've got this mid-level dry slot to the east of this compact inner core here. So outflow is definitely acting as a counterweight to any southwesterly wind shear that might evolve. And look at those big time echotops there going high up into the tropopause. So I'll be back live a little bit later on this morning. I'm going to hop on back over to Facebook and do another live with this supercell storm very close to the center. And then I'm going to pop back here on YouTube and then go once again as well. I'm talking about the H-WRF, Peter. That's a model HWRF. It's basically a high-resolution hurricane model. And that model has been really good so far at depicting the evolution of this structure and the intensification on approach to northwestern Florida of this tropical cyclone. But there you can see the echo tops definitely pumping up 55, 60,000 feet up there with that supercell storm just to the northwest side of that center. So thank you everybody for joining me for this weather report. I'm going to keep slinging these live updates as this thing is heading toward the northwestern portion of Florida. And I will add some moderators as well on here. Yeah, I do need some moderators. Who do you guys recommend would be a good moderator? I think I can just click on your names. Thank you, everybody. Never stop chasing.